So basically, there were certain questions asking, given a angle, right, which could be any quadrant. So you know a trig function of an angle. So you want to find out the value of the remaining 5 trig functions. Okay. So like in this case, we're given sine alpha. Let's go ahead and write it down. So letter A, right? So we know sine alpha is 4/5. Okay. And you should, draw or even just picture this kind of a right triangle right away, right? Because that's, you can even see what those numbers are trying to tell you, right? So those are the easy numbers. So by all means, draw a sketch, label the angle alpha, and label the sides, right? Even there's a missing side. So opposite 4, right? Hypotenuse 5, and using the Pythagorean theorem to find out the remaining side, which is going to be 3. Okay, so that tells you pretty much everything you need to know about this particular angle alpha, even all the remaining trig functions. But now the problem is when it comes to cosine alpha, it seems obvious. You can just do the adjacent of a hypotenuse, right? 3/5, right? But the question is, why do you think they're telling us that angle alpha is in the second quadrant? You probably remember that over the past, there was only one scenario that you do have to worry about the quadrants, right? We have the rule says all functions, right? All 6 functions are positive in the first quadrant, right? Or the angles are in the first quadrant. Then in the second quadrant, only sine and its reciprocal, which by the way is cosecant, right? Or positive in the second quadrant. Then you get tangent, cotangent, positive in the third quadrant, and a cosine and its reciprocal, which is secant, right? So a small trig class, right? All functions, sine, tangent, cosine, right? Therefore, in the second quadrant, cosine has to be negative, and it's as easy as you just putting manually a negative sign, right, to account for the correct value of the cosine. Okay. All right. So we do the same thing for letter B, and it's even easier since angle beta is in our first quadrant, right? So we just go ahead and let's say sine beta is 1/2, right? So you're gonna go ahead and draw another triangle, right, with angle beta, opposite 1, hypotenuse 2, right? The remaining side is radical 3, right? So a very special 30, 60, 90 triangle if you identified it. Now, if you're looking for cosine beta, right, it would just be as simple as radical 3/2. No need for a negative sign since beta is in the first quadrant, right? All functions are positive. Okay. Now, if you're wondering, okay, what is the point of getting these two guys? Since we've done it before. Well, for this particular checkpoint question, they're actually trying to be, guiding you guys through the whole process. So now, if you're looking at letter C, how would you find out cosine alpha plus beta? Since you don't know what alpha beta are, right? But wait a second. Do we actually know anything about alpha beta? Or let's say, is it possible for you guys to solve for the actual degree or radius for alpha beta, given the information so far? For beta, that might be pretty easy, right? But technically speaking, what about alpha? Is it really that impossible? Well, it's not that straightforward, right? Because it turns out that alpha is not a acute angle, right? But remember that you have the tool of inverse functions, right? Now, of course, it is not as easy as beta, since if you now go ahead, you guys, if you have a calculator with you, you guys invert either sine alpha or cosine alpha in such a way to get alpha in, let's say, degrees. I just make it a bit easier to work with. All right, can anyone type up and tell me what alpha is supposed to be straight from your calculator by inverting sine or cosine? So 53, right? Okay, what about cosine? You do it from cosine? Everyone else try the inverse cosine of negative 3/5. Tell me what you get. Okay. So let's say if you do it from sine alpha, right? So alpha is inverse sine of 4/5, and the quintessence is about like 53 or something, right? So let's go with just roughly 53 degree. But if you do it from a cosine, negative 3/5. Okay, can you tell me what that is? If you do the inverse cosine? 127 degree, right? So, guys, what's going on here? Why these two functions are not giving me consistent answers for alpha? Which one is correct? Or any of these two is correct, or maybe they're both wrong? What did it say about angle alpha? It's quadrant 2. So if you had to guess what alpha is supposed to be, what do you say? 127, right? That's the second quadrant angle. So now here's a very interesting question. What's wrong with 53? It's quadrant 1, right? But I thought that alpha is quadrant 2, right? Shouldn't the math just figure it out? Well, then look at what we just did. We feed 4/5 to the sine inverse. How does sine inverse know that this angle is not in the first quadrant? It doesn't have any idea, right? And this is why, if you want to do in a more, let's say, kind of an intuitive way, because I saw a student in the third period or second period, I forgot, who was trying to compute what alpha, beta are, which is actually a perfect way to do it. Because to me, thinking that, oh, you just want a cosine of some of these two angles, right? If you know angle alpha is 127 and beta is, what is that? Beta is 30 degree, right? Okay, so add it to be what? 157 degree? How easy is that to compute cosine 157, right? Type it up. But the problem is, there's a little trap, right? When you compute alpha, if you decide to use the sine inverse, it doesn't give you the right answer. And I don't want to spend too much time explaining why, because you know that it's all about the domain and range of inverse, right? And you've seen things like that. So now you make the choice. You either know that alpha has to be in the second quadrant, so maybe do both and see whichever is going to get you the right answer. Or let's say, in this case, the standard way to figure it out what cosine alpha and beta, cosine alpha plus beta, is to expand it using the sum, formula of cosine, right? Now, so let's take this chance to recall the structure of this formula, cosine alpha plus beta. First off, the structure is exactly CCSS, right? And it's the opposite side in between. So it'll be cosine alpha, times cosine beta minus, right, sine alpha times sine beta. So now you see that we have everything, right? We can just plug in. So cosine alpha is negative 3/2. No, I'm sorry, 3/5, right? Cosine beta is radical 3/2. minus, right? Sine alpha is 4/5. Sine beta is 1/2, right? So we get is 3 radical 3, which is negative, right? Over 10 minus 4 over 10, right? Now, if you do want to somehow, combine them, you don't have to, because I don't see anything any better if you do that, right? But you could, right? Negative radical 3, 3 radical 3 minus 4 over 10. Now, if you do put it in a decimal form, since you type up everything in the calculator, you'll be fine, absolutely fine in the test, right? It doesn't have to be, the kind of a radical form. Okay. Now, just do a quick sanity check. So we figured that alpha has to be 127. I mean, roughly, right? Beta obviously is 30 degree, right? So why don't you type up cosine 127 plus 30, which is cosine of 157 degree, right? And see how much you get. And it's not going to be exact, right? Since I did run up or down, whatever, right, over here. But you will see that whatever you get from cosine 157 degree will be close enough to this guy, right? If you were to put it in a decimal form. Okay. But please, at this point, or let's say we're preparing for our third test, I would say that you're slightly better off to go with the standard way of doing it. Show me how to work, because this will be, like, say, to me, a perfect effort kit. It can check a lot of things, right? And it will be also relatively student friendly for you to actually show me enough work to score all the points. Okay. So now, how about you guys try letter D real quick? Since it's already trivial now. You have everything, right? Sine, cosine, alpha, beta. You just have to recall, how sine alpha plus beta can be expanded, right? Then figure out the algebra. Then we'll move on to the next thing. All right, go ahead and compute the letter D. What is sine alpha plus beta? we're asking about the cheat sheet, right? Right. So I believe that most of you should be able to finish it or about to get to the final answer, right? But it's pretty straightforward now, right? Just go ahead and again, try to remember, right, the structure, right? Always try to put it down without looking it up, if you could, right? Try 3 more times, you get pretty fast. Now, one of my students asked me yesterday that he said that, hey, I know these formulas very well. Can I just quickly get to the substitution and also work out a number, right? If it's F per Q, he lose any points for not showing me the formula. So to be honest, if it's an F per Q with that many parts, if the student are able to show me, the substitution and the right answer, then yeah, if I don't see the formula for the letter D, I will still give it 4 credits. But the problem is, what if, see that when I was writing down, when you guys were working on it, right? So I noticed that I didn't put 4/5 for sine alpha. Because there's so many things going on, right? And I've been putting sine beta and write down 1/2 and I erased it. In a test, is it possible that you were looking at the wrong thing and put it down? That means you got a wrong substitution. I'm assuming that there's no time for you to check your work, right? How are we supposed to know there's a typo there and you got the wrong answer? And now without any formula, how am I supposed to know you did the right thing? The substitution was wrong, right? Or I can assume that you got the wrong formula in the first place, but you didn't show me that you know the right formula. So for me, that's an awkward situation. I might have to give a 0 for that, right? So I'm not saying that you have to show me everything. I'm just letting you know that you might be risking, losing more points that you're supposed that you really have to by not showing me the formula or not showing me something that I've been showing you, the whole time, right? And this is why, if I could, I'll write down as many important steps as possible. But I do understand that sometimes, we could skip something, right? But not going to be those important steps. Right? Again, it's up to you. If you feel like skipping some steps in the test, just be careful with, the steps that you're skipping might score, might get you some points for. Anyway, so yeah, if you want to take a picture to refer to this problem later on, you could do that. And please remember that I've showed you yesterday, which I will do that again. So question 9 to question 20 on the quiz packet are about 6.2. And there are a few questions that you could work out. Please give it a try just by referring to, checkpoint 5, right? The one we just did. Like question 13 and question 19 and 20. Okay, those are very similar questions. So like I said, please, if you can just spend some time, maybe 15, 20 minutes to work out those 3, because hey, you just have your fresh memory about what we just did in class, right? Give it a try, have your work, organizing your notes, right? Then we're ready to come in, in a week or so. Then just review it right before the quiz and get it done, okay? Now, since I wasn't in a rush, so let's look into those formulas in a more, let's say, traditional way. Because, what I feel like that when I just tell you what the formulas are, so that loses the whole point of an instruction, in math classes, right? And I even, told my students in the past, like, the difference between, college classes, and maybe regular high school classes that, yeah, I mean, yeah, professor might have more freedom in, controlling their classes, right? But the thing is, soon you'll realize, let's say if you go to any colleges that you dreamed of, professors don't really go with the book. Sometimes they don't even use the book, even though they ask you to buy it. But the purpose of my walking with a sheet of paper that he wrote maybe an hour before the lecture and come and do whatever he wants. Right? But if you're able to appreciate those kind of not very organized notes, right, or lectures, and try to extract as much important things as possible from his lecture notes, you will see that what really make this person, like the expert in the field, is actually what the person is so proud of and sharing with you, which you might not realize or appreciate during the class. Okay, but by all means, when you're thinking about those formulas, have you wondered that? I mean, how did they actually came up with these formulas, right? And it turns out that there is a straightforward, but not that easy, when it comes to algebra, but straightforward way to show that formulas, come from whatever you already know. All right. So let's take a close look at the second identity. Right. So let's prove it, and then I'll tell you what to do about the remaining, without going through the detailed work anymore. But number 2 is a little bit easier to prove. But they're all very similar. So first off, let's draw an angle alpha. And here, even though that the alpha looks like a second quadrant angle, right? It doesn't have to be. Right? It could be some kind of a random generic angle. And the reason why I put it in a second quadrant is just to make it a little bit bigger to draw something in a nicer way. Now the circle is a unit circle. Okay, that means the radius is always 1, right? And I picked the point, let's call it P, which is on the unit circle, right? And you know that we track the angle alpha and its trig function values using the coordinates of the P, right? So now, once again, I probably have asked you to do this for quite a few times. Can anyone tell me how sine alpha and cosine alpha are defined in terms of the x and y coordinates of the P? So basically, is cosine alpha x or y? I'm talking about the unit circle definition of the trig functions. Cosine alpha has to be x, right? It's the adjacent side over the hypotenuse. Yes. So I'll put cosine alpha for the x coordinate of the P and sine alpha, which is the y coordinate of the P, right? Is that okay? Just, the x and y, right, for the P. And now we'll do another point, let's say a point Q. And that point is associated with a different angle, let's say beta. Okay. So now, this time, I want you to tell me what should I put for the coordinates for Q in terms of beta. Anyone try it? Donovan? Sine beta, yeah. It's not too bad, right? Of course, you do have to memorize this, but you do can you can follow the pattern here. So I'll connect P and Q to form the segment PQ. So how would I compute the length of a segment PQ? Using your basic geometry or algebra knowledge. How do you do that? Given the coordinates of Q and P, you want to find the distance between P and Q, right? What do you do? Is there a formula? So you can just subtract the coordinates and square them, add them up and stuff, right? That what they call it, distance formula, right? Okay. Now, but you know that distance formula has a square. Sorry, has a radical, right? So we don't like to deal with radical. Let's square the distance. So I don't have to take the radical anymore, right? So it will be cosine alpha minus cosine beta square plus sine alpha minus sine beta square, right? So again, if you wonder what's the radical for the distance formula, well, notice that I wasn't just calculating the distance, I was calculating the distance square, okay? And you see why, you know, we try to lose the radical. All right, so you probably don't see what's the point of doing this. The next step is really the brilliant idea behind the proof. So you guys see the triangle OPQ, right? So let's rotate this triangle about its vertex at point O. We'll rotate the triangle in a clockwise direction for angle beta. You can imagine what the triangle looks like after you rotate it clockwise for angle beta. And I'll use a different color to draw it. Okay. Maybe this kind of color, maybe it's no good color here. All right, here. Now, start with the easy one. So let's say, what about the point Q? If I rotate it clockwise by angle beta, where should I find the new point? The Q is going to rotate. It's going to follow the circle, right? Where do you think the Q is going to get? Yes, you'll get to here, right? And let's call it Q prime. You know, it's a Q, but you know has been rotated. Can you guys guess what will be the coordinates of Q prime? What should be its x? Look, it's on the x-axis, and it's on the unit circle. Should the x coordinate of the Q prime be just 1? Right, it's on a unit circle, right? Exactly, right? There you go, right? Now, what about the point P? So it's going to rotate, right? You can kind of see like it's going to go this way, right? Let's say it's about here, P prime, right? So now this is the hard part. What should be the coordinates of the P prime? I'm going to have some space here. Well, the P prime is not on the y or x axis, so you couldn't really get either 1, 0, 0, 1, right? But don't you want to know what will be the angle associated with the P prime? Say it again. No, well, it looks like pi over 6, right? It was not. It's a pretty general thing. Now, let me ask you, if I form the triangle O, P prime, Q prime, are the two triangles congruent to each other? OPQ and OP prime Q prime, right? They're congruent, right? Because you just rotated. If they're congruent, that means the angle P prime OQ prime must be the same as angle POQ. So how much is the angle POQ in terms of alpha and beta? Does everyone see that? This angle here, alpha minus beta. See where we're going to? That's what we want to get, right? Therefore, the angle associated with the P prime is nothing but alpha minus beta. So now you guys tell me what should be the coordinates for P prime. Anyone can tell me? Cosine of alpha minus beta, right? Sine of alpha minus beta. Okay. Now, this is even a better part. What do you think will be the distance between P prime and Q prime? Yes. What part? Okay. Because the graph gets messier, so that's why you probably don't see it. Now, now, Rebecca, I said that Q is pretty much just starting from the X rotating this way, sweep out angle beta. So that's how big the angle associated with the Q is. That's beta, right? Now P is starting from the positive X, rotating all the way here, sweeping out a bigger angle alpha. What is the difference between these two angles? Or how much you think will be the angle P O Q? Isn't that the bigger angle alpha subtracting the smaller angle beta? Is whatever that's left over, right? Now remember that this is the angle in between these two sides, right, of the triangle POQ. But if I rotate this triangle this way, I'm not supposed to change the angle in between. Therefore, the angle between P prime O and Q prime O will be the same as before. So it is still the same angle that you're looking at, right, between these two sides. It's hard to track. That's why I have to draw it carefully and remind you what you're looking at. But if you take a close look, you'll see it. So now my question was, how much would you say will be the distance between P prime and Q prime? How would you calculate it? All right, so P prime, Q prime, right? And again, let's do the square of the distance. I know that it seems complicated, but let's just write it down. Let's see what happened later. That's the structure for the difference formula, right? We're subtracting the x coordinates, right? So we're looking at cosine alpha minus beta minus 1. Now, the y coordinate is going to be as simple as just sine alpha minus beta, right? Subtracting 0, so you don't have to do it. So you might say, what's the whole point of calculating these two distances? Should these two distances are the same? Should the segment PQ equal to the segment P prime Q prime? Because they are congruent triangles, right? So now, let's say, since P prime, PQ, the same length as P prime Q prime, we can conclude an identity that goes like cosine alpha minus cosine beta square plus sine alpha minus sine beta square must be equal to here. Now I hate to have so many round parentheses. Let me do the bracket. Okay, cosine alpha minus beta minus 1, right? Getting squared minus plus. Sorry. Sine square alpha minus beta. Okay. Do you guys all see that I'm just equating these two expressions? So now you know that if I said that I'm going to prove the second identity, right? And now we get to some sort of identity which is way more complicated than what it needs to be. That means you have to simplify it. But now you know that it has to work out. This is like in a quiz, you know what's supposed to be the identity, right? You just try to show me how to go from your complicated form to the simple form, that I proposed, right? But now ask yourself, what could you do to both sides of the equation to simplify it as much as you can? What do you think? Well, let's say starting from the left-hand side. Is there anything you feel like doing? Or Would it be too much to ask you to square or expand, the perfect square here? You guys know the, let me put it on. All right, so A minus B square is A squared minus 2AB plus B squared, right? That's called the perfect square trinomial. And I do have the so-called A, right, minus the B. If I square it, I'll just go by the formula here. So I'm looking at cosine squared alpha minus 2 times cosine alpha cosine beta plus cosine squared beta, right? That's what I got by expanding the first, perfect square trinomial. Now I'll do the same thing for sine alpha minus sine beta, right? It's the same format, but you have sine squared alpha, right, minus 2 sine alpha sine beta, right, plus sine squared beta, okay? Now before I get to the left-hand side, the right-hand side, any simplifications can you do? Do you notice any interesting combinations of the squares of the sine and cosine? Cosine squared alpha, sine squared alpha, they add up to be 1, right? See those two guys? And also cosine squared beta, sine squared beta, add up to be 1, right? So the left-hand side becomes 1 plus 1, right? So it'll be 2. But there's something that you couldn't do anything, right? Just leave them there. So it'll be negative 2 cosine alpha cosine beta minus 2, right? Sine alpha sine beta, okay? Again, before I move on, do you guys know how I got that 2? 2 pairs, right, of Pythagorean identities. So now let's take a look at the right-hand side. I mean, you're going to square it again, right? It's the so-called A minus B is just 1, right? So you get cosine square alpha minus beta, right, minus 2 times this guy times 1, right? So it'll be cosine alpha minus beta times 1, okay? Plus, again, you have a 1 square, which is still 1, plus sine square alpha minus beta, right? Now again, do you notice that this guy and that guy add up to be 1? You also have another 1. They add up to be 2, right? 2 minus 2 times cosine alpha minus beta. Now, see what we have done. The left-hand side works out as 2 minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta, right? It must be equal to the right-hand side, 2 minus negative 2, 2 minus 2, right, times cosine alpha minus beta. We cancel the 2, right? And we can cross out the 2 since there's a common factor, right? There's a negative sign across the board, cancel them out. So you arrived at cosine alpha cosine beta plus, since you divide out the negative sign, sine alpha sine beta, it must be cosine alpha minus beta, right? That's the identity we're trying to prove. Okay. All right. But I think that now is a good moment to ask you guys remember the identity instead of remembering how it gets derived, right? Because that's right. So you better remember the identity, right? Okay. All right. So now, one more. Not proving one of those four because you know it's gonna be hard, right? So let's take some educated guess based on what the formulas you already know. All right. So let's say, can I move on to the next page? Yes. Or take a picture. All right. Or Rebecca, you can email me. I'll send you the work. Now, let's say if I have to figure it out, what tangent alpha plus beta could look like. So I want to remind you that what is tangent? Sine over cosine, right? And that's why we're not that crazy about tangent anymore if I know what's going on with the cosine, the sine and cosine, right? So now again, this is again a chance for you to show me that you already memorized these identities, right? So first off, how do you expand sine alpha plus beta? Sine, cosine plus cosine, sine. There you go, right? Good. Now cosine alpha plus beta. Minus, very good. Yeah, minus sine alpha, sine beta. Okay. So now, but you see that if we have sine cosine for the sum and difference formula for sine and cosine, if we're trying to find out the formula for the sum of difference of angles for tangent, you're expecting that you should have a whole lot of tangents going on, right? And the way to get it is as simple as by dividing every single term on the numerator denominator by this guy. All right, so let me show you that works out surprisingly well. All right, so this is the numerator, right? So you see that I was dividing two terms in numerator by the same denominator here, and I'll do the same thing for the two terms in the denominator. And let me highlight the things that are dividing out across the board. It's this guy.
But why did you do that? Wait, why?
Well, you'll see that in a second.
Why?
Okay, so now what is this guy? Sine over cosine, tangent alpha. All right, so these two cancel, right? Now, those two cancel. What about this guy? Plus tangent beta. So that's how easy the numerator becomes. Now, these two completely cancel, right? What about this guy? There's a one here, right? Tangent alpha, right? What about this guy? Tangent beta. There you go. And that's the formula for sum of difference, sum of the angles for tangent. Now, guess what the difference is going to look like? Alpha minus beta. Can I just replace all the beta in the first formula with negative beta? We can, yes. All right, so now you guys notice, you guys remember that tangent is even or odd. Look it up, it's on the cheat sheet. You still have it. Tangent is odd. If it's odd, that means you can take that negative sign out, right? So that means it becomes, on the numerator, tangent alpha minus tangent beta. But on the bottom, if you take out that negative sign, that cancels out the negative sign in the front. So you have 1 plus tangent alpha tangent beta, right? And those are the two additional formula for the sum and difference. Okay. So I hope you see that. You're better off to remember all 6, right? Sum and difference for sine, cosine, and tangent. Okay.